On day 3 of section 2.3, what I specifically want to talk about is those higher order derivatives. We mentioned the other day and we wrote down their notations. So we wrote down the notations of second derivative, third derivative, fourth derivative. We can take a derivative as many times as we wish. Most of the time we're going to talk about just second derivatives. So the first example I'm going to give you is just one of a second derivative. In order to be able to take a second derivative, you first have to have the first derivative. So we will go ahead and find the first derivative of secant x. We were to memorize those trig derivatives the other day. So those derivatives, one of them is secant x, and the derivative of secant x is secant x tangent x. Now that you have the first derivative, you are now able to find the second derivative. The second derivative requires the product rule. Notice my notation for the second derivative, f double prime. To take this derivative, then, we simply say to ourselves, the first, which is secant x, times the derivative of the second. The derivative of tangent x is secant squared x, plus the second, which is tangent x, times the derivative of the first. The derivative of secant x is secant x tangent x. I could leave my answer in this form, but I will go ahead and take the time to simplify this. This simplifies into secant cubed x plus secant x tangent squared x. That is as far as I am able to take this simplification, or this being able to simplify. This next problem, it starts out by saying to find the higher order derivative. It gives me the second derivative, and I now have to find the third derivative. So in order to find the third derivative, all we need to do is take the derivative of the second derivative. Notice the notation I'm going to use for the second derivative is the f double prime. I am going to go ahead and rewrite the second derivative with a negative exponent. That way, it does make finding the third derivative much easier. The third derivative then is f triple prime. And I'll take the derivative of the 2, which is a 0, so I will not write that. And then I will take the derivative of the negative 2x to the negative first by multiplying negative 1 times negative 2, which is a positive 2. And then I will lower the exponent by 1, which gives me a negative 2. F triple prime simplifies to be 2 over x to the second. I will continue with the next slide on the next screencast.